The use of SI system provide all scientists and engineers with common language of measurement. That means if a measurement is carried out in chemistry, measurement of length, it will be in meters. If it is measured in physics, it will also be in meters. If it is measured in biology, it will be in meters. The same way, measurement of light intensity, how bright a light is. If it is done in chemistry, it will still be the candela. If it is done in physics, the same thing, mathematics, the same thing. So they now have a simple language that interconnect all sciences together. And that is the use of this SI unit. SI unit prefixes. Now we have certain abbreviations that are used to represent SI unit. The SI system utilizes a standard system of prefixes to the basic unit that allows them to become relevant to the descriptive of relative magnitude. For example, when reading about chemical kinetics, which is an aspect of chemistry that has to do with chemical reactions and the pathways in which the reaction takes place, you may encounter the terms meters, milliseconds. These are smaller seconds, a fraction of a second, or nanoseconds. Meaning, if you see ms, you can see in the screen, you see ns. It means milliseconds for ms and nanoseconds for ns, respectively. The milliseconds is 1/1000 of a second. If you take 1 second and divide it by 1000, you have a millisecond. And the nanoseconds is 1/1 million of a second. That means if you divide 1 second by 1 million, you now have a nanosecond. It can be expressed in standard form as 10 times 10 raised to the power of -9 seconds. Brief review of the basic SI units. If you see a table, unit name, the first column. The second column is unit symbol. The third column is quantity name. The fourth column is quantity symbol. The last column is a dimension symbol. The unit name is the name of the unit used to measure. For instance, the meter. The symbol for the meter is M. Next, we have length. The symbol for length is L. It could be length as in measuring a straight line between two parts, or in a circle, measuring the distance from the center of the circle to the circumference, which is also known as radius. So it is either it is measuring a separation between two parts, or it's measuring the distance from the center of a circle to the radius. You use R, it's called radius. The dimension is known as L, it's represented by L. That is the symbol used for calculating the quantity. Next is kilogram. The kilogram is a unit for measuring mass, how heavy something is. You measure it in kilogram. Most times you see items like bag of cement, you see it is written on it 50 kilograms. It shows the weight of that cement is 50 kilograms. Now the kilogram is abbreviated in kg, small k and small g, as a unit of kilogram. Then it's used to measure mass. The quantity measured there is mass. Then the quantity symbol is M, the dimension used for the calculation, derivation of the formula to produce a mathematical equation for it is capital M. Then the second is the unit for measuring time, standard unit of time. It is abbreviated small s. It is used to measure, the quantity measured is time. Then the quantity symbol is small t, and then the dimension, which is the symbol used to derive mathematical equation for it, is capital T. Next, we have the ampere. Ampere, its unit is A. The ampere is a symbol for measuring electric currents. We have, it measures electric current. The quantity symbol is small r, is I, while the dimension symbol used to derive a mathematical equation for it is capital R. Next, we have Kelvin. The Kelvin, the unit symbol is capital K. It is used to measure thermodynamic temperature. How hot an object is or how cold it is known as the temperature. To measure it, you use the Kelvin as a unit. Then the quantity symbol is capital T, while the dimension symbol, which is used to derive mathematical equation for it in engineering calculations, is theta. You can see there. Then next we have the candela. The candela is used to measure how bright light is, the brightness of a light, which is referred to as luminous intensity. The unit symbol is small d, CD, while the quantity symbol is L subscript V, and then the dimension used for the mathematical calculation is J. Then the next is the mole. In chemistry, we measure liquid symbols or we measure solutions. A solution is when you add a liquid and a solid chemical into a liquid, it dissolves in the liquid and it forms what is known as a solution. Now, to measure it, it is measured in mole. The mole is referred to as the amount of a substance. The unit symbol is MOL, mole, and then the quantity symbol is small n, while the dimension symbol used to derive mathematical equation is capital N. Next, you will see on the screen, we are looking at SI unit prephysics continuous. Now, we are talking about prephysics. There are smaller units to measure very small, minute quantity of objects. For instance, if you check in your stock of items in your house, you see maybe things like toothpaste, even Maggi cube. If you look on it, you see the weight is expressed in small gram. If you see tablet like drugs, they are expressed in milligram. That means very small quantity. You cannot use larger value, the standard value, kilogram, to measure a small particle of a drug. So there are smaller units to measure very small items. Those smaller units are the ones that are defined under this prephysics. The prephysics gives us a definition for smaller or larger quantity. There are 20 accepted prefixes. A prefix may be used to identify multiples of the original unit or fractions of the original unit. For example, kilo denotes a multiple of 1,000. So there are 1,000 meters in a kilometer. You see, in the conversion factor, the meter and the kilometer both measure distance, but the kilometer measure a larger distance than the meter. If you get 1 meter, 1 meter, 1 meter, and sum them up to 1,000, it gives you 1 kilometer. So the kilo there added to meter is a prefix for meter, and then it gives a larger value. This is the use of the prefix to either get larger quantity measurement or get smaller quantity measurement. Therefore, there are 1,000 millimeters in a meter. Similarly, in chemistry measurement, we measure smaller quantities of unit because when you are carrying out maybe reactions, you want to produce drugs in pharmaceutical research, you carry smaller measurements. Now, they are measured in either milligrams or millimeters, which means if you have 1 millimeter, 1 millimeter, 1 millimeter, and sum them up to 1,000, it gives you 1 meter. Now we'll see the table here shows standard prefixes for the SI unit of measurement. First, in the table, you will see at the top of the column, we have name, multiples, and if you come down, you have fractions. If you go horizontal, you have name. The first one is the deca. Next, you have hecto, kilo, mega, giga, tera, peta, exa, zeta, and then yata. All of them are prefixes. Now, let's go down. If you look at first, we say symbol. These are symbols representing all those prefixes. For deca, the symbol for representing it is DA. For hectare, the symbol is H. Kilo, the symbol is K. We have used that already when we said kilometer. The kilo is added to a meter and it forms kilometer, giving larger values of a meter. Then we have the mega, and then we have giga. The symbol for mega is M. The symbol for giga is G. We have tera. The symbol for tera is T. And then peta. The symbol for peta is P. Then exa. Exa has a symbol as E. Zeta symbol is Z. And iota symbol is Y. Now let's see the quantity, the values, the factor now. The deca represents 10 times of a size. For instance, if you say decameter, that means adding meter to deca. Decameter means 10 of a meter. 1 meter, 1 meter, 1 meter, up to 10 times they have decameter. It is expressed in standard form as 10 raised to the power 1, which means 10. The next one is hecto. The hectometer, if we are using meter, for instance, which is the unit of measuring length, hectometer, the hecto represents 10 raised to the power 2, which is 100 times of the usual size. So if you say hectometer, it means 100 of a meter, 100 times a meter. 1 meter, 1 meter, 1 meter, sum up together up to 100. You now have hectometer. So the hecto, when you add it to any size, maybe hectogram, it means 100 of a gram. So like that. Then the next one is the kilo. We have used kilo previously. We use kilo when we say kilometer. The kilo is expressed as 10 raised to the power 3, which means 1,000 times of that size. If you are discussing the meter or you are dealing with the meter, if you put kilo to it, it means 1,000 of a meter, making 1 kilometer. If you are dealing with gram, if you put kilo to it, it is now a kilogram. That means 1,000 of a gram is equal to 1 kilogram, just that way. Then, next one now is the mega. The mega is 10 raised to the power 6, which means 1 million times of the size we are discussing. Now, if you are dealing with, let's go to another one. Maybe you are dealing with a mole, and you say you want to consider megamole. The megamole means 1 mole, 1 mole, 1 mole, up to 1 million times put together and give you the megamole. So the megamole is 1 million times of a mole. Megameter, 1 million times of a meter. And then megagram, 1 million times of a gram. Now, the same thing holds on, like the giga, the same thing, 10 raised to the power 9 is a billion times. 1 billion times of a gram is a gigagram. 1 billion times of a mole is a gigamole. In the same way, all true. Then you have the tera. The tera is 10 raised to the power 12. That means 1 and 12 zeros added to multiply to what you are dealing with. If you are considering the meter, is 1 times 12, 1 times 1 and 12 zeros, which is going to be over a trillion. And same way, you go to peta, exa. The peta is 10 raised power 15, 15 zeros attached to it. The exa, if you say hexameter, that means 1 meter, 1 meter, 1 meter, up to 10 raised to the power 18, 1 and 18 zeros. And then you have the zeta is 10 raised to the power 21, 1 and 21 zeros. And then iota, these are very large sizes that can be used in very advanced calculations. Now we are going to go to the second part of the table. The second part of the table is talking about smaller size. We have just finished dealing with larger size prephysics. Now we'll go to smaller size prephysics. In the smaller size prephysics, we start with the deci. Deci, you must have heard something like decimeter. The deci is 1 divided by 10 of the original size. If you say decimeter, it's 1 meter divided by 10. 10 raised to the power 1 minus 1, which means 1 divided by 10. Then we have the centimeter. Now the centimeter is 10 raised to the power of is 10 raised to the power minus 2, which means 1 of a meter divided by 100 is a centimeter. That is why in conversion symbol, 1 meter is equal to 100 centimeter, because you have to divide 1 meter by 100 to get a centimeter. Next one is the millimeter, abbreviated as M. In the millimeter, you have to divide the size by 1,000. For instance, milli, we have milligram. 1 gram divided by 1,000 will give you a milligram. And 1 gram divided by, let's say 1 meter divided by 1,000 will give you a millimeter. And also in the mole, 1 mole divided by 1,000 will give you a millimole. Next is the micro. When in the manufacture of drugs in pharmaceutical chemistry, we usually deal with smaller size compounds because you react chemicals together in very minute quantity. You cannot measure them in kilograms, which are larger sizes. You have to measure them in smaller size pre-physics. In such cases, you use things like the milli and the micro. Now, in this case, the micro, represented by mu, a symbol, a Greek letter symbol known as mu, is 1 divided by 1 million, which is expressed as 10 raised to the power of minus 6. For instance, if you consider the length, which is the meter, and you put a prefix micrometer, it means 1 meter divided by 1 million gives you 1 micrometer. If you are manufacturing a drugs, for instance, and you want to mix various chemicals in a small quantity of a drug, you have to put the chemical in small quantities, and those quantities are measured in microns. You see something that will say, okay, we have maybe we have the particular ingredient in 12 microns, we have another ingredient in 5 microns, we have the next ingredient in 3 microns. So they are included in smaller quantities. So the micron is used to measure very small and minute quantities. In recent research, there are even more smaller quantities than what we have now. They call them nanotechnology. There are smaller, they represent smaller quantities, abbreviated by N. When you say nanometer, it means 1 meter divided by 1 billion. That is 10 raised to the power of minus 9. Nanogram, it means 1 gram divided by 1 billion. And also if you say nanomole, it means 1 mole divided by 1 billion. So it's used for very smaller quantity measurement. And that is why the aspect of engineering and technology that deals with very smaller quantities are referred to as nanotechnology. Next one is the pico. The pico is even more smaller, 10 raised to the power of minus 12. So whatever you want to measure, if it is length, it is called picometer. 1 picometer is 1 meter divided by 1 and 12 zeros. That's a very large quantity, about 1 trillion. And then if it is gram, 1 picogram is like 1 gram divided by 1 and 12 zeros. Then we have the femto, which is 10 raised by minus 15, 1 divided by 1 and 15 zeros. We have atto, which is also 1 divided by 1 and 18 zeros. And then we have zepto, which is 1 divided by 1 and 21 zeros. And finally, we have the yecto. These are very, very minute quantity measurement. So all these prefixes are used to either measure, to give the quantity of measurement a larger value or a very smaller value. If you can always inspect items at home, whenever you see maybe cosmetics or whatever at home, look at the ingredient. You see they will be listing some of them in milligrams. Some of them will be listed in micrograms. And then when you have large quantities of them, maybe you may see a bag of an item that is bought. Go and look at the ingredient, the size. Sometimes they say 50 kilogram, 20 kilogram, and these are large quantities. So that is how it is used in measurement. Okay, here we'll look at conversion between units. We now learn how to convert units because a measurement may be given in 1 unit. and you want to represent it in a smaller or a larger unit, you have to do some mathematical calculation will lead to the conversion. We have conversion between units. Yes. Some of the things that we measure in everyday living are, first, we measure time, we measure temperature, we measure mass, which is the weight of an object. We measure distance or length. We measure area. We measure volume. We measure speed. We measure money. And then we measure capacity, which is volume of liquid. We also measure amount of substance. We measure light intensity, that is the brightness of a light. It's most common. Okay. Can you hear me?
Breaking.
Can you hear me now?
Yes. Yes, we can
Okay.
hear you.
Is it okay right now?
It's okay now, but like when you're talking, you're always breaking.
Okay, once you have an issue, let me know. The following units are most commonly used, and it is important to remember their symbols or short form. We have quantity, the name of units, symbol, and then value. Now, in length, there are various units that are very common. We have the millimeters, is very common. The symbol is mm. And then in unit conversion, 10 millimeter represents 1 centimeter. Then we have the centimeter. The symbol is cm. 100 centimeter is equal to 1 meter. Then we have the kilometer. The symbol is km. 1,000 meter represents 1 kilometer. Next is mass. Mass can be measured in very common units of mass that are used today. We have the milligram. The milligram is abbreviated, is symbol as mg. Now, 1,000 milligram represents 1 gram. Then, next we have the gram. The gram is abbreviated as G. We have 1,000 gram is equal to 1 kilogram. Next is the ton. The ton is a very large unit. It's represented as T. The abbreviation symbol is T. We have 1,000 kilogram is equal to 1 ton. When you are measuring very large objects, let's say the weight of a ship, you measure them in tons because it's very heavy. You know, you want to measure the weight of an aircraft, you measure in tons. Okay, next we'll go on time. The very common units of time are, we have seconds, minutes, hour, and day. Now, the symbol for second is S. 60 seconds represent 1 minute. This is very common. Then, next is the minute. The symbol for minute is MIN. 60 minutes represents 1 hour. Then the hour, the symbol for hour is H. 24 hours is equivalent to 1 day. Okay, then it continues. We know very well that we have 30 days that represents a month, sometimes 31 days. We have 28 days in the month of February, and so on. But these are very common ones we will discuss. Temperature. The Kelvin is a symbol for temperature. 1 unit of temperature is the Kelvin. The abbreviation symbol is K. Then, in conversion terms, 273 Kelvin represents 0 degrees Celsius. Then we have another unit of measuring temperature. It is the degree Fahrenheit. Fahrenheit, this is quite common. The symbol is degree F. The degree there is represented by that small o as a subscript, superscript, small o, degree F. Now, in conversion terms, 32 degree Fahrenheit is equivalent to 0 degree Celsius. Now, so we use basically Kelvin and degree Fahrenheit, very common in measuring units of temperature. Next, we will look at the area. Now, area is a surface of an object, a measurement of the surface of an object is the area. Now, let's see, square millimeter, one of the smallest units that is very common is a square millimeter. It is mm raised to the power 2. Now, in conversion terms, 1 centimeter square is equivalent to 100 millimeter square. Then we have the square centimeter with abbreviation symbol cm raised to the power 2. In conversion, 1 meter square is equivalent to 10,000 centimeter square. This is centimeter. 10,000 centimeters square. 10,000 centimeters square. Then next we have the square meter. 1 meter square represented at m raised power 2. Okay. Now we have the 1 hectare meter. 1 hectare. A hectare is usually the measurement of the size of a land. 1 hectare is equivalent to 10,000 meters squared. That is the length and the width multiplied together must give 10,000. That represents 1 hectare. The hectare has an abbreviation symbol HA. Cubic meter is one of the commonest units for measuring volume. Now, 1 millimeter cube is abbreviated as mm raised to the power 3. In conversion terms, 1 centimeter cube is equal to 1,000 millimeter cube. Now, the cubic centimeter, the unit is given as cm raised to the power 3. 1 meter cube in conversion term is equivalent to 1 million centimeter cube. And then the cubic meter has its abbreviation symbol as the mm raised meter, m raised to the power 3. Next one is the capacity, which is the volume of liquid. In measuring the volume of liquid, it is measured in milliliter, liter, and kiloliter. These are the commonest symbols for measuring volume of liquid. Now, the milliliter is abbreviated as ml. Now, in conversion terms, 1,000 milliliter is equal to 1 liter. Then, 1 liter, the liter is abbreviated as L. In conversion terms, 1,000 liter is equal to 1 kiloliter. While the kiloliter is the larger unit here, it is abbreviated as KL. Next is speed. Speed is the rate of change of distance with time, or how fast you can cover a particular distance. Determine the speed of an object. It is mostly used in engineering and physics calculations. Next, speed. We use the meter per second here to measure speed. And we also use the kilometer per hour to measure speed. The kilometer per hour is a larger unit of speed, while the meter per second, which is standard, is a smaller unit of speed. If you sit close to the driver's seat in the front of a car, you will see a meter that measures the speed of the car. It is written in kilometer. it increases from 0 up to a certain point. And then when the car starts slowing down, it returns back to 0 again. That is called the speedometer. It is abbreviated in kilometer per hour. It measures how fast the car is moving at a particular time. Next, we'll see is the amount of a substance, which is the mole. The unit is the mole. The abbreviation is MOL, mole. Then finally, the luminous intensity, as I said earlier, is used to measure how bright a light is, the brightness of a light. That's luminous intensity. It is measured in candela, and the symbol is CD. Now, we will look at some examples how to convert from one form to another. Example 1, let's convert 245 centimeter to meters. 245 centimeter to meters. 1 centimeter, as we said earlier, is equal to 1 meter is equal to 100 centimeter. Now, 1 centimeter is now going to be 1 divided by 100 meter. So that 245 centimeter, which we want to convert now, is now going to be equal to 245 divided by 100 meter. And if you do that very carefully, you move the decimal point behind 5 forward 2 places, it will come and settle between 2 and 4, and that will now be 2.45 meters. Is that example clear?
Yes. Yes.
Okay, let's see example 2. Let's convert 2.3 kilogram to grams. Now, we want to move from kilogram to gram. How do we convert 2.23 kilograms to grams? 1 kilogram is equivalent to 1,000 grams. Now, 2.3 kilogram, it's going to be 2.3 times 1,000. And if you multiply that carefully, you will have 2,300 grams. Now you move the point from 3 backward 3 places. If you move it behind 3, 1, and you move it 2 other places, you add 2 zeros. It will now be 2,300 grams. Example 3, let's convert 2.50 hours to seconds. 2.50 hours to seconds. Now, talking about time this time. 1 hour is equivalent to 60 minutes. 1 minute is equivalent to 60 seconds. That means 1 hour is going to be 60 times 60 seconds. Now we want to convert 2.5 hour to second. It's now going to be 2.5 hour will now be equal to 2.50 times 60 times 60 seconds. So if you multiply this carefully, you will have 9,000 seconds. 9,000 seconds. 60 multiplied by 60, carefully done, will give you 3,600. If you now multiply 3,600 by 2.5, carefully done, taking note of the decimal points position, you will end up with 9,000 seconds. So you practice this letter. Is that clear?
Yes.
Okay. Example 4. Let's convert 50 degrees Fahrenheit to degrees Celsius. This is very important. Most oftentimes, the conversion is necessary. Now, there's a mathematical equation that is used to convert from degree Fahrenheit to degree Celsius. Now, temperature represented by T in degrees Celsius is equal to, open bracket, temperature in degree Fahrenheit minus 32, close bracket, times 5 divided by 9. That's the formula. You have to
Now, what
practice.
is that 32?
32 represents the relationship between the degree Fahrenheit and degree Celsius. Earlier, if you go backward where we were relating, you can see under temperature, I say 32 degree Fahrenheit is equal to 0 degree Celsius. That is where 32 came from. Is that clear?
Yeah.
Okay, so let's go back now. Now, let's convert 50 degree Fahrenheit to degree Celsius. The formula is here. Temperature in degree Celsius equals to temperature, open bracket, temperature in degree Fahrenheit minus 32 times 5 over 9. Now, you will substitute the 50 degree Fahrenheit where we wrote temperature degree Fahrenheit. So it's 50 minus 32 bracket close times 5 over 9. So if you subtract 32 from 50,
Yep.
you will get what? What will you get? 50 minus 32.
18.
18.
18. Okay. So you now multiply. You multiply 18 by 5. 18 times 5. Do you have pen and paper?
Multiply 18 times
Yeah.
5 over 9.
18 times 5. Do that. Let's see. Tell me.
Is it not 18 times 5 over 9?
Yes, yes. So you times 18 times 5. Whatever it gives you, you divide it by 9. Times 18 by 5. And tell me, let me see if you can get what it is.
What if you just do 18 times 5 over 9 and then you say, and 9 in 18 is 2, and then you just multiply that by 5?
Okay, that makes it easier. Beautiful. And it will give you 10 degrees Celsius. Beautiful. Good knowledge of math. Okay, let's take the next question. Question 5. Let's convert 280 millimeters squared to meter squared. Now, from our previous discussion, we said 1 meter is equivalent to 1,000 millimeter. Now, put in brackets, 1 meter squared is equivalent to 1,000 millimeter, all in bracket, raised to the power of 2. Now, what do? You multiply 1,000 times 1,000. That will give you 1 million millimeter squared. That means 1 meter squared is equivalent to 1 million millimeter squared. Now, but what if you are looking for 1 millimeter squared? What will you do? You will divide that 1 meter by 1 million. It will now be 1 millimeter squared is equals to 1 divided by 1,000 meter squared. But the question says, convert 280 millimeter squared to meter square. So what do? Now, 280 millimeter square is equivalent to 280 divided by 1 million meter square. So when you do that carefully, you start from behind the 0, you move the point 6 places ahead. It will now give you 0.000280 meter squared. Is that clear?
Yeah.
Beautiful. Next question now. Let's convert 2.156 meter cube.
So can I explain that one again?
Okay, the first one. Question 5.
So you're breaking.
Right? Let's 2. You said?
Okay, you're breaking.
Okay. Okay, let's wait a little. Is it clear now?
Yes.
Okay, example 5 once more. Let's convert 280 millimeters square to meters square. Now, I said earlier on, let me take you back. where we're measuring distance. You see, we said 1 millimeter, 10 millimeter is equal to 1 centimeter. So if you multiply 10 by 100, it will give you 1,000. So it now be 1,000 millimeter equals to 1 meter. That was where we got this. So in conversion factors, 1 meter is equivalent to 1,000 millimeter. Now, but we are talking about area squared. So you square the 1 meter. 1 meter raised to the power 2 equal to 1,000 millimeter raised power 2. You know, in mathematics, whatever you do to the left-hand side, you also do it to the right-hand side. Then, equal to, when you raise, you know, 1 meter raised power 2 still remains 1 meter squared. But on the right-hand side, 1,000 millimeter raised power 2 will give you 1,000 times 1,000 millimeter squared. And if you times 1,000 by 1,000, it's just like putting 3 zeros and another 3 zeros. It will now give you 1 and 6 zeros, which is 1 million millimeter squared. That means 1 meter squared is equals to 1 million millimeter squared. Okay, but we are interested in getting a millimeter in meter. What do? We now say 1 millimeter squared is going to be 1 divided by 1 million millimeter squared. So having gotten this, you can move ahead and introduce what you are looking for. 280 millimeters squared will now be equal to 280 divided by 1 million meter squared. We are now moving to meter. So what do? The point at this point is right now is behind 0 in 280. So you move it to the left-hand side, forward, ahead of 0, ahead of 8, ahead of 2. Move it 6 times because you have 6 zeros. And you now get 0.000280 meter squared. Any question?
No, sir.
Okay, it's clear now. Now let's take 6. Let's convert 2.156 meter cube to centimeter cube. We are looking at volume now. Volume have to do with 3 sides of an object, which is raised to the power of 3. Now, I want to convert 2.156 meter cube to centimeter cube. 1 meter is equal to 100 centimeter. Oh, okay. Now, there's something you will do. We did, the conversion was done in square. The 1 meter here is to be raised to power 3 equals to 100 centimeter. You will also raise it to power 3. If you do that, if you raise 100 to power 3, that means 2 zeros, 2 zeros, 2 zeros up to 3 places. And that's going to give you 1 and 6 zeros. That will now be 1 million centimeter cube, not square as it is on the screen now. It's going to be cube. Then 2.156 centimeter cube will now be 2.156 times 1 million centimeter cube. That means you will move the points to the right behind 1, 5, and 6, 6 places. If you do that, it's going to give you 2,156,000 centimeters square. You will do that later. Can you do that briefly? Change the meter, the square to cube and see what it will give you. Well, whether you get 2,156,000 meter cube.
Sir, can I please repeat what you said to do again?
Okay, I said we have 1 meter squared, right? In question 6. I want it to be 1 meter cube equals 100 centimeter cube, both sides. Then you now multiply 100 3 times. It will now, that is a cube. It will now give you 1 million. Then you now multiply 2.156 by 1 million and tell me the size of the figure you will get. Do you understand?
Yeah,
Okay, do that briefly now. Tell me.
Yeah, it's not centimeter cube. Why is now written centimeter squared?
You say you understand, and what?
I said that in number 6, it said convert the in centimeter cube. Why is it
Yeah.
now written in centimeter square?
Yeah, I want you to make it in cube and tell me what you will get. Put a cube where you see square. Put a cube. And when you put a cube, the 100 now will be 100 times 100 times 100, 3 places. And that will give you 1 million. So multiply 2.156 by 1 million. And then read out the figure you get for me. Yes, what did you get?
2,156,000.
Very good, very good. Centimeter cube. So
So I got 2,156,000.
very good. Very good. You both got the correct answer. Okay, can we move on now? Now let's see number 7. It says, let's convert 3,600 kilometer per hour to meter per second. This is speed now, converting larger value of speed to smaller units of speed. Now, previously we discussed that 1 kilometer is equal to 1,000 meter. And again, 1 hour is equals to 60 times 60 seconds. That means that 1 kilometer per hour, which means 1 kilometer divided by 1 hour, is equivalent to 1,000 meter for the kilometer to meter over 60 times 60 seconds for the hour to second. Next, 3,600 kilometer per hour is now equal to 3,600 times 1,000 divided by 60 times 60 seconds. So now you now start dividing. If you multiply 60 by 60,
So you're breaking again.
Okay, let's wait a little. Okay, is it clear now?
Yeah.
Okay, I said now 3,600 kilometer per hour is equal to 3,600 times 1,000, that is meter, divided by 60 times 60.